the first course in the Data Science Specialization series. Here, we will be going over the basics of data science and introducing you to the tools that will be used throughout the series. So the first question you probably need answered going into this course is, what is data science? And that is a great question. To different people, this means different things, but at its core, data science is using data to answer questions. This is a pretty broad definition, and that's because it's a pretty broad field. Data science can involve statistics, computer science, mathematics, data cleaning and formatting, and data visualization. An Economist's special report sums up this melange of skills well. They state that a data scientist is broadly defined as someone who combines the skills of software programmer, statistician, and storyteller/artist to extract the nuggets of gold hidden under mountains of data. And by the end of these courses, hopefully you will feel equipped to do just that. One of the reasons for the rise of data science in recent years is the vast amount of data currently available and being generated. Not only are massive amounts of data being collected about many aspects of the world in our lives, but we simultaneously have the rise of inexpensive computing. This has created the perfect storm in which we have rich data and the tools to analyze it, rising computer memory capabilities, better processors, more software, and now, more data scientists with the skills to put this to use and answer questions using this data. There is a little anecdote that describes the truly exponential growth of data generation we are experiencing. In the 3rd century BC, the Library of Alexandria was believed to house the sum of human knowledge. Today, there is enough information in the world to give every person alive 320 times as much of it as historians think was stored in Alexandria's entire collection. And that is still growing. We'll talk a little bit more about big data in a later lecture, but it deserves an introduction here, since it has been so integral to the rise of data science. There are a few qualities that characterize big data. The first is volume. As the name implies, big data involves large datasets, and these large datasets are becoming more and more routine. For example, say you had a question about online video. Well, YouTube has approximately 300 hours of video uploaded every minute. You would definitely have a lot of data available to you to analyze, but you can see how this might be a difficult problem to wrangle all of that data. And this brings us to the second quality of big data, velocity. Data is being generated and collected faster than ever before. In our YouTube example, new data is coming at you every minute. In a completely different example, say you have a question about shipping times or routes. Well, most transport trucks have real-time GPS data available. You could in real time analyze the truck's movements, if you have the tools and skills to do so. The third quality of big data is variety. In the examples I've mentioned so far, you have different types of data available to you. In the YouTube example, you could be analyzing video or audio, which is a very unstructured data set, or you could have a database of video lengths, views or comments, which is a much more structured data set to analyze. So we've talked about what data science is and what sorts of data it deals with, but something else we need to discuss is what exactly a data scientist is. The most basic of definitions would be that a data scientist is somebody who uses data to answer questions. But more importantly to you, what skills does a data scientist embody? And to answer this, we have this illustrative Venn diagram, in which data science is the intersection of 3 sectors: substantive expertise, hacking skills, and math and statistics. To explain a little on what we mean by this, we know that we use data science to answer questions, so first, we need to have enough expertise in the area that we want to ask about in order to formulate our questions and to know what sorts of data are appropriate to answer that question. Once we have our question and appropriate data, we know from the sorts of data that data science works with, oftentimes it needs to undergo significant cleaning and formatting, and this often takes computer programming/hacking skills. Finally, once we have our data, we need to analyze it, and this often takes math and stats knowledge. In this specialization, we'll spend a bit of time focusing on each of these 3 sectors, but we'll primarily focus on math and statistics knowledge and hacking skills. For hacking skills, we'll focus on teaching 2 different components: computer programming, or at least computer programming with R, which will allow you to access data, play around with it, analyze it, and plot it. Additionally, we'll focus on having you learn how to go out and get answers to your programming questions.